Hey guys, Joe Pye here at Advanced Innovations. Welcome back to the shop. I recently posted a video on how to turn exceptionally thin wall cylindrical shapes on the lathe, and this is the part 2 or the follow-up to that. This is where I'm going to show you the same exact philosophy of a big bite and go for it technique to turn exceptionally small diameters for extended lengths. Now, depending on how you support or accommodate the material that's hanging out after you cut, you could realistically apply this technique indefinitely and cut some really long, really skinny stuff. Anyway, going to take a walk out in the shop, going to set up a piece of, let's say 303 stainless steel in the lathe, and we're going to turn it down to about 30 thou, and why not, let's go for about 2 inches. So if somebody said, okay, let's do that 30 thou for 2 inches, you would laugh, because under normal circumstances it would push away. If you had a live center in it with any kind of material on the end, the pressure from the center would bow it and it would just basically not work. So one shot, and we're going to creep it out of a 5C collet as we go, and it should work like a charm. Let's take a walk. Okay guys, the tool that I'm going to use for this particular demonstration is a KTG-PR 123A Kennametal. This is a TPG 321 insert, 15 thou radius on the edge. This is a triangular insert with a positive edge to it. It's flat on the top, does not have a chip breaker built into the insert. It's a 15 thou radius on the nose, 3 usable points of the tool. It is not a reversible insert, so you can't flip it upside down. And it's very reasonably priced for the work that it will perform for you. And I'll tell you, this is my go-to tool holder. This is a great little tool holder. Let's pop it in the machine, cut something exceptionally small. Well, very much like the thin wall tubing video, the secret to cutting a small diameter over a long length is take one big bite. This is 1/2 inch diameter 303 stainless. I know I said I was going to use 3/8, but the only 3/8 I had was 17.4, and that's a little bit more expensive. So we're going to go with 1/2 inch. The TPG tool that I just showed you on the bench is going to bite this down to a 30 thou diameter, and I'm going to cut this at about, let's say 1300 RPM, about 3/4 thousandths of an inch on the feed rate, and we're going to use Tap Magic for stainless as a lubricant. Now there will be smoke, but when the smoke clears, you're going to see a nice little diameter turned on that. And as far as the advancement is concerned, I am going to advance this out of the collet while the machine is running, so I can get a visual on the concentricity, and we'll see how far we can go before this thing climbs up and over the tool and breaks off, which is a very real possibility because the diameter will be so small. As you get further into the part, that little diameter is going to want to whip, very much like if you had a long piece of material hanging out the back of your lathe when you turned on a high speed, you know, you're going to get that helicopter effect. So when you do something like this, if you're going to go real far with it, it's advisable to put a piece of material in a drill chuck or something with a hole drilled in it and get real close to the material, so the material you're cutting can feed into some type of receiver feature and keep that whip from happening. I'm just going to see if I can get lucky and how much I can get away with here. So off camera, I established my setting for my tool, and we're going to cut. Let's see what happens. Going to try for about 500 at a shot. As the tool advances into the cut, when I'm done with the cut, I'm going to back the tool out just a hair and move the tool off the part to avoid any encounter with it if it is whipping out. When I advance the material, I will play with the 5C closer until I get a visual on the material that I just cut. As the tool comes in for the next cut, I will stay away from the diameter that I established until I am just about to the shoulder. Then I'll dial into my number and allow the tool to proceed. So you will see minimal impact marks for each index of the material. Hopefully. Let's see what happens. not even want to touch then. Now when I start this back up, I'm going to be watching for an eccentric condition right here. I do not want to see this running out. Ideally, I don't want to see the end running out either. But as this little diameter gets longer, the likelihood of this starting to go eccentric from the RPM is going to be greatly increased. So let's see what we come up with. I like it. I'll get close without touching it. Just before the tool makes contact with the face, I'll try to synchronize the plunge at the same time and minimize the step marking. Okay, progress check. We are looking at about 1 3/16 inches. And I dare not put a micrometer on that right now, because if I do, I'm going to bend it. I know it, so I'm not going to touch it. I'll put a camera on it and mic it up when I'm done. But for now, I'm just going to trust that my settings are behaving. The longer it gets, the more you're at risk of the part whipping, climbing up over top of the tool and just disappearing. I'm going to feed this by hand. You can start to see some movement in the end of the part at this point. Like I mentioned previously, if you had another piece of material with a hole drilled in it, a piece of plastic held in a drill chuck, you could extend that over top of this part right now and keep that whip to a minimum. Let's see if we're going to make the 2 inches. Got about another 5/16 to go, and we're there. We are starting to experience some whip at the very end, but right here where the cuts are going to blend, it's running nice and true. So I'm going to go with it. Just a safety note before I finish. Judging by the amount of smoke that we have coming off of this tool, you know there's some pretty good heat going on. And the fact that the chips are burning into the brush is another good thing. If you're going to do this, or it's another good indicator that there's heat, if you're going to do this, make sure you do it with adequate ventilation. And if you have any plastic or paper or excessive oil in the bed of your machine, make sure you clear that out as well. You don't want any exceptionally hot stainless or steel chips falling on top of something that could outgas and potentially poison you or make you very sick. So be very aware of that. Let's finish the cut. About 2 inches 070, so that's a win. Let's part that off. I'm going to use the same parting tool that I used on the plastic. And I don't know if you can see that. I hope you can. It's very pointy. It's not going to take much to get through this. Climb up and over this tool in the worst way. So I'm going to beat this part at its own game. Just a little bit bigger.
get a close-up on that on the bench, put a micrometer on it, and we're going to find out together what it looks like. I bet it's pretty close to 30. Let's see. I don't know if you can see that or not. That's about 29 and a half. Let me pop this camera up on a bench here. And we'll do it this way. Let's get a little further into it. 30. Move it down about 3/4. I gotta say, if I paid someone to do this, I'd be real happy. And last but not least, right at the very end. There you go, guys. That is a 1/2,1000th of an inch deviation to the low side, not plus or minus a half total. The finish on the outside is not bad at all. It's 2 inches long. It's 0.30 in diameter. One shot, came out of a piece of 1/2 inch 303 stainless steel. Try that technique next time you got something thin to do. It works well. Thanks for watching. Okay guys, well that is another very good technique for doing exceptionally small diameters. You will have to experiment and get the feel for the material that you're going to start with, how much pressure it can take, is it going to deflect, how far away from the collet can you extend it before you start to see some taper from deflection. Anyway, once you've tried it, once you've done it a few times, you'll get a feel for how far out you can do it. If you have a part of material that you're going to do that on, make sure the material that you start with is relatively cylindrical and straight. I mean, lay it on a surface plate and roll it and look for it to whip, because chances are if you're going to do that step technique with any type of collet, if the part is bowed when you start, chances are the part you're going to end with is going to be bowed as well. So make sure that the part you start with is nice and straight. Anyway, that's all I got. Try it. It works. Joe Pye, Advanced Innovations, Austin, Texas. I'm out.